Hello, Algebra 2 students. I appreciate you finding time to get your notes taken care of. We are still on the discussion of polynomials, and as you could probably guess from our discussions the other day or yesterday about multiplying polynomials, today we're going to be talking about division. There's actually two different methods that we're going to go through on how to divide polynomials. The first one that we're going to look at is called the long division method. So please copy down the title, Dividing Polynomials by Long Division. Our objective for this day is the students will learn to divide polynomials by the long division method. Now, if you need more time, as always, press pause, or you can move the video back, rewind the video, and go ahead and press play when you're ready to move on. Now, I'm sure long division is a method that we probably don't have a lot of fond memories about from back in the elementary days, but hopefully now that we're older and smarter, it won't be quite so intimidating. Okay, so we're going to start off working a problem very similar to what you might have had to work back in elementary school, and it is simply doing long division involving two constants, 59 divided by 4. Now, 59 is what we call the dividend. It is the value that is being divided into, and 4 is the divisor. It is the value that is actually doing the dividing. Now, when we set up a problem like this from back in the day, it looked like that. We used that little division structure. A lot of elementary school teachers called it a house or whatever. And the dividend always went in the house. Okay, that's the part that is being divided into. Okay, easy to remember. It's the one that's being divided into. It goes into the house. Okay, the divisor, which is the 4, it goes outside of the house. Okay. Now the question is really a very simple one. How many times will the 4 go into the leftmost digit of the dividend, which is the 5? I had an error in my notes and I scribbled it out there. Okay, so we're trying to get the 4 to divide into the leftmost value, which is the 5. If it will divide in, then we're going to divide it in. If it won't divide in, then we'll scooch over one more digit and we'll try it again. But in this case, the 4 will divide into the 5. Okay, it will go in one time. Now, you don't have to copy down a brand new problem or anything like that. You can add these steps onto the 4 divided by 59 that you've already written down. So you don't have to keep writing the problem over and over again. Okay, so we decide that the 4 will go into the 5 one time. So we put a 1 above the 5 up on top of the house. Okay, that 1 multiplies by our divisor, which is a 4. 1 times 4 is 4. We take that product and we write it down underneath our 5. So there's a 4. Now the thing that we did from here is you subtract this value away. We are removing that 4 from the 5. We decided it would go in one time. Once it goes in one time, it is no longer there. So we're taking that 4 away. 5 minus 4 is 1. Okay. Now, in order to be able to continue the division problem, what we did was we brought down the next digit, okay, from the dividend. So we've already tended to the 5 in the dividend. Now we're looking at the 9. Okay, so we're going to bring the 9 down, and we're going to write it directly next to the 1 that we had left over. So we have a 19. So now the question becomes, all right, 19, how many times will 4 go into U? Okay. Well, after thinking about it for a moment, hopefully you arrive at the conclusion that 4 will go into 19 4 times. Okay, so we're going to write a 4 up above the house, on top, directly above our 9. Okay, and then we say, okay, it's going in 4 times, so we're going to take that 4, we're going to multiply it times our divisor. 4 times 4 is 16. We write that 16 down below this bottom number 19. Okay, now just like before, we're just repeating the process here. We're going to subtract those values, 19 minus 16, and that gives us 3 left over this time. Okay, so you repeat this process until basically you run out of values in the dividend. Okay, well, we are at that point. We have run out of values in the dividend. So here's what happens next. Okay. Since the number under the division structure, the dividend, is all used up, this last number that we are left with, sorry, that should say number, not number. Okay, This last number 3 that we have left over is what we call the remainder. Okay, and a remainder always goes over the divisor at the end of our answer. Our divisor is 4, so we are going to end up with a 3/4 remainder. Okay, and the answer part of our answer, the whole number, comes from this value that we have built on top of the house. It's the 14. So our answer is 14 3/4. 4 went into 59, 14 whole times, and 3/4 of the next time. Okay, hope I didn't bore you to death with that. You might remember this old long division stuff. It's just important that we be able to go through these steps as you're going to see here right now. Okay, now we are going to have polynomials involved rather than just constants. Okay, but the same idea still applies. Okay, so our strategy is going to change a little bit, but the same basic concept. We need to find a way for this divisor, 2, to match the first term of our dividend, which is 2x. When we set up the problem, okay, it looks like this. 2 is dividing into 2x plus 5. And just like before, we are trying to make this 2, the divisor, okay, we want it to come as close as we can get it to the leftmost term underneath the division sign. That's a 2x. So the question we're asking ourselves is, what does a 2, which is the divisor, need in order to be identical to the first term? Well, the first term is a 2x. Well, the divisor already has the 2. So what do we need to finish that off? We need an x. Okay, if we were to multiply by a positive x, that would give us 2x, and that's what we're hoping for. Okay, so multiply 2 by x, and that will give us 2x. Okay, and just like before, when we multiply this value on top of the division sign times the divisor, we write that result down underneath the leftmost value. Okay, what did we do with long division once we got to that point? We subtracted whatever that left term of the dividend was, and this new term that we just invented, we subtracted the 2. Now, if we have done our steps correctly, that term should be eliminated. We should end up with a 0 right there, which we did. Okay. Now the next thing that happens is, okay, once we've dealt with that term, we scooch over and we deal with the next term. So the 5 is going to drop down in our problem. If I can get this slide to cooperate with me. The 5 comes down. Okay, so the same question again. We're repeating the process. What should I multiply a 2 by in order to get me a 5? Now, obviously, 2 doesn't multiply nicely times a number in order to get a 5. We're looking for a whole number, okay? And the closest we can get to getting a 5 without going over 5 is to multiply by a 2. Okay, so we're going to multiply our divisor, 2, by a 2, and that'll give us 4. Okay, so 2 times 2 is 4. We write that down underneath our 5. And just like we do every time, we subtract these values. 5 minus 4 is going to be 1. Okay. And once we run out of values to bring down, okay, the division is finished. Okay, so since the polynomial under the division structure, okay, the dividend, is all used up, we don't have anything else to bring down, then this last, I misspelled number again. Good job, Hill. N-U-M-B-E-R. Okay. This last number, this 1 that we ended up with, is our remainder. And just like before, our remainder goes over our divisor, which was 2. Okay, so our answer is, when we divided that 2 into 2x plus 5, it went in x plus 2 times exactly. But then we had a remainder of 1 over 2. Now, if you notice in this little polynomial, there is some combining like terms that can be done. You have 2, which is a whole number, and 1/2, which isn't a whole number, but it's another real number. We can add those together. That is 2.5. Our result is x plus 2.5. Now, these problems can get a little bit more complicated, obviously, as polynomials grow larger and larger. Okay, so let's take a look at a couple of other type problems. Okay, here we have a trinomial, which is being divided by a binomial. Okay, now obviously, this is a little different. Okay, the divisor, which is x plus 1, is a binomial. There's 2 terms in it. It's going to change a couple of things. Okay, and the 2 things that are critically changed to this is, number 1, there are 2 terms that are being multiplied in each step. Every time we invented a new number on top of the house, okay, that multiplied times our divisor. Now our divisor has 2 terms. So when we invent a new number and put it on top of the house, it's going to multiply by both of those terms. Okay, and the other thing that changes is, since we're multiplying times 2 terms, it is going to take 2 terms worth of space in the dividend before you can divide that divisor in. Okay, let me see if I can show you this more graphically. Okay, here over here on the left, this is the red one, point number 1. There are 2 terms that are getting multiplied in each step. So when we invent a number and put it in there where the question mark is on top of the division sign on the left here, okay, that question mark is going to basically kind of follow the distributive property. It's got to multiply times the x, and it's got to multiply times the positive 1. That's going to give us 2 values to write in underneath the x squared and underneath the negative 9x. Okay, and the blue one, the blue point, said it's going to take 2 terms in the dividend before you can get the divisor to divide in. True enough, x plus 1, that's 2 terms. So when it comes time to divide into the dividend, it's going to take 2 terms worth of space. That means that the first value that we can write on top of the division symbol is going to be over the second term of the dividend, which in this case is the negative 9x. Now, it sounds a little complicated, but I promise you it's not quite that bad. Okay, let's take a look at the problem. Okay, so now our focus here is to get the leftmost term of the dividend to be eliminated. We want it to go away. Okay, so what we're thinking is, at that spot where the question mark is, we need to figure out, well, the question mark is positioned where it is because it's going to take 2 terms to divide into the dividend, and it's going to take 2 terms because the divisor has 2 terms. X plus 1, that's 2 terms. So it's going to take 2 terms on the x squared minus 9x to be able to divide in. All right. Computer's responding very slowly. Okay, so the question is, what does that question mark need to be? What values do we put there so that multiplying it times the x on the divisor will result in x squared? We're trying to match the first term of the dividend, which is an x squared. So what times x gives you x squared? Okay. Well, obviously, if we put another x in there, x times x would give us x squared. So let's do that. Okay, if we put an x above the 9x, okay, that guy's going to come out and it's going to multiply times the x and times the positive 1. X times x is going to be x squared right underneath that x squared, and x times 1 is 1x. Now the negative 9x and the positive 1x, obviously they do not match up, but we're not really concerned about that. We're just worried about the left-hand terms being identical, and they are. Okay. Now, just like we did with long division before, we are going to subtract this value from those values coming down from the dividend. Okay, so we're going to say x squared minus x squared and negative 9x minus x. Okay, now obviously the x squared minus x squared, that is 0. That's what we wanted. The x squared is gone now. Okay, negative 9x minus x is negative 10x. Okay, Now, just like with the regular long division, we are going to bring the next term down from the dividend. So the minus 10 drops down. Now, we repeat the same process again, okay, now trying to, once again, eliminate the leftmost term. So what needs to show up above the negative 10 so that when we multiply it times the x, it will equal negative 10x. Well, we've already got the x, so we need to bring a new negative 10 into the problem. Promise it's not as complicated as it sounds. As you get a little bit more familiar with it, work a couple, it'll get easier. Negative 10 times x is negative 10x. But just like with distribution, the negative 10 also needs to multiply times the positive 1 on the divisor, and that gives us a negative 10. Now we subtract this value. Okay, and in this case, negative 10x minus negative 10x, the double negative becomes a positive, and the x's are eliminated. That's what's supposed to happen. That leftmost term should go away. The negative 10 minus negative 10, double negative becomes positive. Negative 10 plus 10 is 0. Since we have a 0 here, and there's nothing else to bring down, then we have no remainder. Okay, so the answer to our problem is the x minus 10 that's sitting on top of the division, and we have no remainder over x plus 1. Okay, so the remainder actually cancels out. The answer is x minus 10. Okay, now I'm sure there's a fair amount of confusion after looking at just that one example, so obviously we're going to look at another one together. Okay. Now, when doing polynomial division, there's also one other thing to watch out for. You need to make sure that the terms are spaced properly. If terms are missing, we must install zeros for them in order to hold their place. Now, basically what we're saying here is x cubed is the degree or the order. Okay, so x cubed is going to be the highest exponent in our dividend. Okay, but there's no x squared term and there's no x to the first term, but we still have to represent them in the problem. So the x squared and the x to the first are missing. We must hold their place in order to get the spacing in the division problem correct. Okay, so x cubed plus 0x squared plus 0x to the first minus 6. That is actually our dividend. Okay, now let's get started on it again. Okay, obviously, again, it's going to take us 2 spaces, okay, over the dividend because we're dealing with a binomial as our divisor. So the question is, what do we multiply times x in order to match the leftmost term in the dividend? We're trying to match an x cubed, so x squared times x to the first would be x cubed. Okay, but the x squared also multiplies times the negative 2, and it gives us negative 2x squared. Now we're going to subtract this value away. Okay, so x cubed minus x cubed, that's going to zero out. That's good. That's what we wanted. And then on the second term, we're going to have 0x squared minus negative 2x squared. Watch those double negatives. They become positive. That is going to be a positive 2x squared. Okay, so we bring down the next term, which is a 0x to the first. Okay, so once again, now we're going to ask ourselves, what should the next value be above the division symbol? Okay, because we're trying to now get rid of a 2x squared. What times x to the first out there in the divisor, what times x to the first is going to equal 2x squared? Well, we're going to need a coefficient of 2, and we're going to need another x. So 2x is going to be our new value up top. Okay, so we're going to multiply 2x times our divisor. Okay, and that's going to give us 2x times x is 2x squared. 2x times negative 2 is negative 4x. Okay, the left-hand terms match. That's what we want because here in a moment we are going to subtract them from each other. and we want them to zero out. Okay, so 2x squared minus 2x squared is going to be 0x squared. That's going to be gone. That's good. And on the second term, 0x minus negative 4x. Double negative is positive, so it'll be positive 4x. We've got one more term to bring down. It's a negative 6, so we bring it down. Now, once again, we look back up top and say, okay, what needs to go above the negative 6? Okay, what are we going to multiply times x to match that 4x? Well, we've already got the x in the divisor. We need a 4. So we're going to multiply times a 4. Let's see what we end up with. Okay, 4 times the x is going to give us 4x. 4 times the negative 2 is going to give us negative 8. Okay, it's the same routine over and over every single time. Now we're going to subtract. Okay, we're going to subtract those values. Okay, and we end up with a positive 2. Okay, we have nothing else to bring down, so this is our remainder. The answer is x squared plus 2x plus 4, and there is a remainder on this problem. And as you remember, the remainder goes over the divisor. X squared plus 2x plus 4 plus 2 over x minus 2. Okay. Now I'm going to give you a couple of examples. Okay, I feel like you probably are going to be struggling with this. It's going to take a little bit more explanation. So go ahead and copy the examples down. Leave plenty of space so that when we work them together in class, we'll have enough space on your paper. But copy this down. X squared plus 9x plus 14 needs to be divided by x plus 7. If you're feeling a little bit confident, go ahead and give it a try. Maybe you'll get it right. And another example, please copy it down. 2x cubed minus 9x squared plus 15 needs to be divided by 2x minus 5. I apologize for the notes being a little bit lengthy this time, but as you can tell, this does require a good bit of explanation, and it's going to take us some practice in class in order to get it down. Okay, but bring those two examples to class with you tomorrow, and we'll see if we can't figure it out. I appreciate you finding time to do your notes.